så crashede vores database, fordi der var et connection lige på database connections. Så slukkede vi for den, og så tændte vi den først i starten af den her uge igen, fordi der så også lige var noget andet, der skulle lave. Sådan er det jo altid. Og nu er vi back on track. Så vi snakker om, at det vi egentlig har brugt tid på at lave, det andet her, det er en håndfuld VPN-maskiner, en konfigurerbare EC2-instanser, som agerer VPN'er til vores partner, og lave det også som en operator, som bare spækker nogle af dem på de her IP og så videre, så sørger det for måske med Terraform og spænde noget infrastruktur op til fast. Vi er live. Så behøver man slet ikke at kigge herned, så kan man bare sidde og kigge ind i telefonen nu. Er det bortset fra, at jeg skal sige noget?
Det kan godt være, der er en konflikt.
Altså, du skal bare stå sådan helt op mod... Ja, hvis jeg stiller mig, det gør mig lige klar. In the zone. Der er et eller andet med det der i hvert fald. Det virker bekendt.
Det bliver spændende.
Ja.
Så er det godt, vi er live her.
Ja. Har du en idé om lyden der, når du sætter den sådan der, og det er live?
Om det er godt?
Ja. Jamen, du kan høre det.
For at gemme, hver gang du søger, så hver gang du åbner søgen.
Ja, der er en grøn linje, der hopper. Det må vel være godt nok. Tror du ikke? Hallo, 1, 2, 3. Hallo? Ja, der skal vi have... Skal vi have dobbelt på? Ja.
Skal vi to på? Nu siger jeg bare, at det kan godt være, at man overengineerer det her setup, når der er en optag-knap lige her. Men altså...
Hvordan virker det?
Skal vi have tændt på noget lyd for dig, så?
Det tror jeg. Der er lyd på.
Fedt. Vækst.
Det kan ikke være...
Det gør de vel først kl. 8.
Det er ikke sådan en... Nej, folk må spise op.
Jeg tænker, kan du ikke godt, vi kan nå at hente dem i pausen på en eller anden måde? Havde du...
Mig og Michael, vi kommer.
Hvor skal jeg?
Og Terraform sandwich.
Men det kan være, du bare skal have den her på fra start af, Bjørn. Fordi så tager jeg bare den håndhold i stedet for.
Okay. Ja.
Skal du have en hånd?
Ja, tak. Kan du ikke lige preppe?
Sådan er det. Og så bare med en baglum eller et eller andet. Så får du bare lige den her over lige om lidt.
Er den tændt, den her? Det er den ikke nu?
Nej,
du den?
jeg slukker den, ja.
Så hører jeg ikke at sige. Så gør jeg det sådan.
Ja, du. Der var også noget. Kører den.
Ikke nu, er det? Hvornår?
Klokken 5.
Og der er du, nice. Det er heldigt, det der presenter-beskeder virker, fordi jeg har godt nok fået skrevet mange noter dernede, som jeg ikke har nogen idé om.
Okay, du har fået sat det okay der.
Jeg tror, det står okay.
Ja, jeg er lidt red for, om vi måske tømmer Lunoways data-konto lige nu, fordi vi bliver blokeret på netværket, så jeg kører lige over mobilen. Det er jo bare... så er det alle i Luna, der mister deres data. Så kører bare noget mere, og så virker det igen.
What?
Ja.
Kører
på sådan en stor pool.
Den kører jeg vel egentlig også på. Ja. Er det bare alle på
alle, der har Luna abonnement, ja.
Nice. Ja. Du ved, nogle gange så bliver der lige taget nogle genvejhister her. Det sker også.
Skal vi lige...
Så bliver det sådan en rundsling med
så kører det bare.
Nå, jeg tror, vi er live, men... Det bliver rigtig godt for dem, der sidder og hører med lige nu, fordi de hører alt, hvad vi snakker om.
Ja. Skal vi ikke nævne det, der skete i går?
Nej, det er en dum idé. Ja.
Jeg går alligevel lang tid før de finder den.
Ja, præcis.
Okay. Vi skulle være nogen af 60, skulle vi ikke?
Jo.
Hvor mange er der her? 5.
Så jeg har lige på Stejs bare lige fortæller om DevOps Days Aarhus. Så er der DevOps.
Havde du en bog og noget, du skulle have med os? Eller? Nej. Ikke alligevel.
Så skal jeg op og hente det.
Det bliver en anden gang. Ja. Og vi har da også et kamera her. Jeg tror bare, jeg har bare rippet et under med forældre, vi havde...
Inden skuden den...
ja, undskyld. Beklager. Det var der ikke nogen, der hørte.
Ja, 58 står der lige nu. Vi er 49. Det er okay.
Hvordan sletter man alt på sådan et kort? Eller? Er det egentlig...
format. Nå, det Canon, det er ikke sådan lige... Jeg har en Nikon.
Man ser NCS fat 32.
Så en stor magnet. Kortet ud.
Undgå spejlet.
Nej, det er ikke...
Magneten skal gerne rime på melodien.
Sådan. Det er vist fint. Uden blitz, tak.
Går på P, som har sådan
Det har den.
ikke på auto, fordi så slår den blitzen op. P.
Ja, men jeg har også en uden blitz. Auto uden blitz.
Ja, P også.
Jeg skal have et billede af det der. Ja, det er nok ikke helt okay, det der. Vi har en viewer. Stærkt.
Skal vi prøve at tale op? Vi beder lige alle om
Ja.
at se den undervejs.
Du kan nævne, at vi for første gang streamer det.
Jeg har helt slidet mig det der stream der.
Nu jeg skrev lige til Jesper Christensen i går og hørte, om han kom. Han er så fødselsdag i dag. Men han var totalt excited over, at der nu var optagelser og livestream. Livestream var måske ikke sæsset.
Ja,
Det var super fedt.
det er jo nu, altså det setupet, det er bare at trykke stream, og så er der...
Det er bare tryk.
Ja.
Ellers så skulle jeg gøre det, at... Men spørgsmålet om, vi skulle gå op til sandwiches med, så du snakker, fordi når du er færdig, så skal vi jo sådan set bruge dem.
Det er selvfølgelig en god pointe. Altså, jeg har ikke så meget spændende at snakke om. Du kan se den bag.
Er det ikke bare, I laver en mere ting til?
Jo.
Jeg siger ikke, I er ligesom Solando.
Men det er vi.
Og
Vi er ret seje.
ja.
Kommer til tiden, eller?
3. Det skal jo stå herinde, jo. Det skal jo stå herinde, jo. Okay. Okay, I think we are ready to get started. Welcome to today's meetup. It's good to see so many people in here. It's awesome that we can gather all of you guys with some hopefully interesting talks. Why is there 2 keyboards? Use this. If it works. It doesn't.
It worked on my computer.
Call IT.
Yes.
Is the slideshow?
Yay. Okay. Awesome start to our new streaming of this meetup. So yeah, we are streaming this meetup today. We are trying at least. This is our first time. We just bought some gear and hopefully it works. So we have a camera down here and we are sort of mixing the input from the output from the machine down here and trying to create a live stream. And we will record this as well and see if we can edit something afterwards and put it up on YouTube as well. It's going to be live on the Cloud Native Nordics YouTube channel. So yeah, find it in there and we'll probably post something on Twitter or something afterward as well. But I know you don't use Twitter, so yeah. you need to use Twitter if you want to find these videos, probably. I forgot to say thank you to Luna for actually providing some money to buy this gear. So yeah, thank you for that. My name is Kasper. I work at Luna. I'm also a Cloud Native Computing Foundation ambassador. So I try to bring whatever Cloud Native to Aarhus and to the Nordics as well, because we are part of this bigger community called Cloud Native Nordics, which I'll come back to in a minute. Yeah, blog. It's been 2 years ago since I wrote something actually, so I can't call myself a blogger anymore, I guess. But it's up on KubeCloud. It's Raspberry Pis and Kubernetes. In the organizer group of Cloud Native Aarhus, we had to say goodbye to one of our co-organizers. Daniel chose to step down as an organizer. So I'm not sure if he's here today. No, he's not. But yeah, I just want to say thank you for his time and all his hard work. And instead, we got a new one. Mike, who is down here on the first row and also going to be presenting today, is going to be a new co-organizer of the Cloud Native Aarhus meetup group. He works at Humio. So yeah, he has been one of the primary go-to of Cloud Native Aarhus, even though he lived, what was it, an hour and a half away or something like that. So he's very passionate about this group. So that's pretty awesome. So please welcome him as a new organizer of this group. And Cloud Native Nordics. So I'll just skip to this slide. We are now 13 groups within the entire 5 countries of the Nordics. We just recently got Stavanger on board, which actually means we are now 6,600 people across the Nordics, which is quite a lot of people, and we're doing a lot of cool stuff. And we have this the YouTube channel that I talked about before. This is the first time in Aarhus that we're streaming, but in Finland they have been doing this for a couple of months. So there's videos up there from their meetups as well. So check it out. We also have a Slack channel, so if you want to ask questions afterwards or connect with people, it's a good place to do this as well. And Aarhus, the Aarhus group, this group actually just, 3 hours ago, just got the member number 1,000. So that's actually quite an accomplishment for us. And actually, we are the biggest of all of the groups in the Cloud Native Nordics, just by a bit. So that's actually pretty cool that we sort of beat both all the capitals of the Nordics in Aarhus as a quite smaller city than all of the other cities. So thank you. It's you guys that are coming to our meetups, and I want to be part of this. So thank you to you for actually being part of this. So yeah, I think we are the capital of the Nordics as it is right now. Yeah, so the big question, what is Cloud Native anyway? We've been talking about Cloud Native in Aarhus for a couple of years now, and there's always new people coming in and joining this community. So I just like to sort of mention what sort of show the definition, just for people to know what it actually means. So this is the definition. There's a lot of words up there. I highlighted a few of them just to sort of make it more easy for you guys to understand. But it's about scalable applications. It's public, private, hybrid clouds, can be any cloud. It usually has some kind of containerized environment. It uses maybe service meshes, microservices, mutable infrastructure, and all of these things are sort of ways to actually implement Cloud Native. This also sort of gives us loosely coupled systems and gives us resilient systems and manageable systems and observable systems. And combine that with robust automation, you get something that's really nice to work with, and you can deliver features pretty fast. Then we have the Cloud Native Computing Foundation, which is sort of the ecosystem around many of these projects. And it's open source everything, and it's vendor neutral. And that's how it's supposed to be. It's pretty awesome that no vendor can sort of decide or do anything sort of for themselves. It's a community-based thing. And of course, this leads to high impact changes and frequent changes and predictable changes with minimal toil. That's sort of one of the goals of doing Cloud Native and implementing Cloud Native. Yes, and there's a lot of projects in there. This is probably an old slide. New projects graduate all the time, and new projects come into the sandbox. But this is just to say there's these 3 different sort of stages within the Cloud Native Computing Foundation. We have sort of the sandbox, which is sort of very early stage projects. Then they can mature and become an incubating project, and then finally graduate. And graduate means that there's a lot of sort of many enterprises and stuff like that has sort of adopted the technology, and it's sort of a proven technology. So that's what sort of the graduated projects mean. All right, my time is up. But today's meetup, you've probably seen it because you're here. It's about Kubernetes operators and Terraform providers. We have Bjørn and Mike talking about this. Agenda, you've seen that. I just want to give the microphone to today's sponsor, Effico Pragma, just to give him a few words.
Do we have a Macinator that can change the slides on this Mac? Can you do that? Are you certified?
Okay, cool.
How did you right click on a Mac? Okay. Yeah, hi. It works. No, I just want to say welcome. So we are basically the plan B. Usually that doesn't sound really cool, but whenever we can't find a venue, then we say, well, let's see if we can borrow this great room from AU, the University of Aarhus. I'm from Pragma. My name is Henrik Høgh. I'm even on Twitter. I'm so lucky I have an email as well. I'm on LinkedIn. That's basically spam mail from recruitment. What I work with is cloud native stuff and Atlassian stuff. So I'm a CKA. We are certified something provider of the cloud native. Oh, sorry. Yeah. Hey, internet. And we're also an Atlassian Platinum partner where we do a lot of stuff there. I have a lot of certifications there as well. And we're called Effico Pragma now. We used to be called Pragma, and soon we'll probably just be called Effico. Who knows? We merged with a big Finnish company, so that's why. I just want to tell short some of the things that might be interesting for you. I don't want to tell how many customers we have and all that stuff, because that's really boring and not impressive, but that's another thing. So one of the things that might interest you is that the 2 interests I had, Atlassian and Cloud Native, I basically joined those and made Ask, Atlassian software in Kubernetes. It's open source, so you can deploy Jira, Confluence, Bitbucket, server or data center into Kubernetes. That's really nice. And how many of you know DevOps Days? Okay. So that used to be in Copenhagen. Now the next time it's actually in Aarhus. And we got this new fancy logo. And it'll be in June. And it's the same team that organized it. Some of them are actually from here in Aarhus. You can get some early blind tickets now. Cheap, I guess. Yes. So if you want to know more about it, there's a link. Also, there's a call for paper if you want to talk at that kind of conference. I did last time. It was really awesome. It was a great event. Also, they have something called DevOps 2020 in Finland, a big conference in Helsinki. Yes, you should probably check that out. I don't know. And that's what I wanted to harass you with. I think I'll just get out of the way now and leave it to the professionals. So, thank you. I'm part of the organizer group, or co-organizer. Just what? You broke the Mac. We need someone to operate this highly intuitive.
Mention Twitter and
yes. So if you're on Twitter like me, please go and hashtag or tag or whatever it's called on Twitter. I'm not a pro. the Cloud Native Nordics and Cloud Native Aarhus and take some pictures and say, yeah, it's awesome, you should have been here, something like that. It will be really awesome. We have the Slack channel. How many of you are on the Slack? Not everybody. Huh, you should be. It's really awesome. We just got some new channels, and I kickstarted one of them at least. Had a great discussion. Yeah. Are you, what?
Can you continue?
Yes.
Yes. Let's put it up there. We actually will have the next meetup is also something.
You need to be on the internet.
Yes. So, yeah, tweet, yada yada yada. Next meetup, it's gonna be the March 10th. It's gonna be a kind of different meetup. We want to do something called open space or on-conference style meetup, where there's no agenda. It's basically you guys that sort of decide what we need to talk about, what's interesting to you, and we can learn from each other. That's sort of the idea. So it's going to be something where you guys come down here. I have this problem. I have this thing I would like to discuss. Post it up on the board, and we vote on the different topics, and we select the highest voted thing, and we go out in groups and talk about those things. And hopefully that's going to sound interesting to you. If it does, it's not created yet, but hopefully it's going to be up tomorrow, so you will be able to sign up tomorrow. And we don't want to see that video. And then I'm going to hand it over to Bjørn as our first speaker today about, I can't even remember the title, but it's a long title. It's something with compliance in Kubernetes and operators and Postgres and something.
Yada, yada, yada.
Give him a big round of applause.
Thank you very much. Just wiring up stereo microphones. No. All right, yeah. Sorry about the extremely long title. I've reduced it just a bit. Let's see, I just need my speaker notes. And they appeared over here. Looks good. Maybe. All right, I think this works. So, thank you very much, Casper. I'm here to talk about mainly Kubernetes operators, and I'm going to put it in a maybe not so fancy title, talking about compliance in this. Yeah, the title is Compliant Postgres Access Management with Kubernetes Operators. So just a short word about me. My name is Bjørn, and I work as a web architect at Lunar, and I've been there since 2017. That's my Twitter handle. Feel free to reach out with any questions. So today we're going to talk about who we are, just short about Lunar and the journey we're on, and then we're going to talk about the what and the why in compliance. Why is this even interesting to talk about? Maybe it isn't. I'm going to summarize that into the challenge we're facing, and then we're going to talk about the implementation. And spoiler alert, the implementation involves Kubernetes operators. So, who is Lunar? It's a bit dark, but we are a 21st century bank. That means we're trying to build a bank in a new way. We're gonna try to make a only digital bank, and no branches, no clerk behind a desk in every small town handing over money. It's all digital. You got a mobile app, you got a chat system with the supporters, and that's all you need. And that should fit all your needs. And of course, we're going to do this a bit more fun than mainframes. We're building on cloud-native software and the philosophy regarding this. We're going to try to move fast, hopefully faster than all the traditional banks, but let's see how that goes. So far, it's been pretty great. And we're on a journey. I'll come back to that. So some boring facts according to Henrik about the company. We're plus 100 employees, 150,000 users. A bit technical, we got around 100 microservices running on 3 clusters. And 25% of the employees is engineers. So we're getting bigger and bigger regarding to the team size, and that imposes some complications. So, what and why compliance? Let's see why this is. How can compliance be interesting, really? It might not be interesting, but it is a requirement because we got a license to build a bank. That is back in August 2019. We got a license from Danish FSA, Financial Supervisory Authority, so we can do banking business. With this comes a lot of regulation, and I say a lot of regulation. We need to be compliant in all sorts of ways. So what we're trying to do in the journey we're on is building a bank from scratch that is no legacy systems except our own, no mainframes, let's see, no branches, as I said. We're gonna not put up some data center with laser security and a bank vault with 10 inches thick iron walls, and so it's 100% digital. We got no cash, we got no physical money. Everything is on the internet. Yeah. So it turns out that this is hard. Doing compliant things is not logging into a database and just fixing this record. This user's email was something else, and we're just going to fix that. No, that's not how it works. So we need to be very, very careful not to do something wrong regarding regulations, and we need to have good answers when questions come. So when the regulation, the Danish FSA comes and say, why did this developer have access to this user's data? Or they ask, why does any developers have access to user data? We should be able to answer clearly and to tell the process of how they got this data, how they got available and what they did to it. And not the least, why they needed access to the data. So there's a lot of things about audit, there's a lot of things about release processes, review, availability. If a bank goes down for a day, that is not well looked upon. You should be able to use your credit card, and there's rules for these things. So we need to look into this. So to put it in a bit more words, compliance is about trust. We need to gain the trust of our customers. We need to gain trust about the FSA, that we're doing things right. The customers is important because it's their money. If you don't trust us, you don't put your money in the app or on your account. So compliance is here to ensure we do a good job about this. History has shown that other banks might not deal with users' money in such a good way. So we should be careful to handle these things great. There's another aspect of this. We need to trust our developers, and developers need to trust the company. If I'm scared of being accused of modifying a user's data or stealing money or something like that in the data systems, I should be confident that there's a clear audit trail indicating that I did not do such a thing. So it's just as much about finding out who did things as much as it is about who didn't do things. Yeah. So we could, of course, make this easy. Say, talk about access to user data. We could just say, all right, let's see, every time a user needs to access data, they need to fill out this form. And just say, why do you need this? What data is it? What time is it? And a signature, and put it up to the manager. And the manager will put a stamp on it, and that's it. yeah, that could work, I guess, and some companies actually do this, but that doesn't really scale. Furthermore, it doesn't really drive the developer experience that we'd like. So if a developer gets assigned a support ticket, they should be able to fix this right away. They shouldn't wait for a manager to put a stamp on some paper or fill out a paper form at least. So we need to make things smarter. And that brings me to the next point. Compliance is always about also about technology. We need to make sure that the processes that we take into account is based on technology, because that has proven to scale really well and makes developers happy. They can keep on moving, and we got strong audits that doesn't have to be looked at by some person that looks, oh well, Björn had access to this data at, let's see, yeah, that date, so that's good. Or did we miss a paper somewhere? So technology is important for us. As I said, we're building a bank from scratch, so we have no legacy systems except our own. And as a startup, you always have legacy systems. But we don't have any mainframes. We don't have software that's been in production for 20 years. That is hard to understand. That was built by someone who could have been your father. Everything is built within the last 5 years, I guess. Yeah. So not so much legacy, I hope. So we use technology to move these things forward, and we question all the authorities saying you need audit, you need availability, and say why, and make sure that we only do the least important things, or the least make it done as fast as we can with the least effort that we think is okay, and the regulatory authorities think is okay. So, looking back, I talked a bit about it already. The company is just coming up on its 5 years anniversary, or birthday, if you will. So it's been quite simple to get access to databases. We had one database. We had a couple of engineers. And did you need access? Yeah, well, you got it already. You knew the password. It was on the paper on that disk or something like that. No, that's not true. Hopefully. Onboarding new engineers and offboarding was rare. And creating new databases is a manual thing. So let's say, as I said, we were using microservices. We got 100. That was not the case back then. But when you need a new database, you would connect to a database using pSQL or some other tool, call the SQL command for creating a new database, and remembering to store the password somewhere safe and all that, yada yada. Error-prone workflows. Furthermore, you had to exec into our VPCs because the database is hosted in AWS. So you need to get into the virtual private networks first. Furthermore, so you have some point in your system where every developer can SSH in and then do all kinds of interesting things. So we don't want that. We don't want that at all. So now we got, as I said, around 25, I think 28 engineers as of today. And we're hiring still. Feel free to join. We got over 100 databases now. And we need to do this more clever than creating them ourselves by hand in shell scripts. So the challenge, I've come up with 4 points, 4 bullets that I like to dive into here. Number 1, we need to keep developers productive. We are a small shop, fairly small shop for being a bank. We need to move fast. We need to deliver features for our users and our investors. And we need to keep our developers happy, otherwise they'll find another job. Number 2, we need to keep user data safe. As I mentioned before, we need to gain the trust of our users. So it is paramount that we keep data safe. We need to be compliant. It's a bit boring, but that's how it is to be a bank. We need to be we need to ensure that the FSA is happy all the time. And not least, we need, or at least we don't want any manual work. So we could keep the developers productive by dedicating someone to sit and do these forms. And that was that person's only job, but that creates manual work, and we can use those resources better. So, diving into each one of these in another order than I just said them, that's going to be fun. We need to stay safe. We need to ensure that the data we keep on our users is safe, it's stored securely, it is their money, and we need to make sure that we can tell if money goes lost or some data is inconsistent. We need to understand why this was the case. We cannot be sure that this never happens, because then we couldn't do anything. We work and release new software every day, so mistakes is going to happen. But we need a way to ensure that we can explain why did this go sideways. Why did this person lose 100 kroners or something like that? So traceability of these things is paramount. And then, as I said earlier, we need to keep developers safe as well. So no false accusations about what did you do with your access, and why did this happen? So clear audit trails for these things is an easy way to ensure most of these points. Then we're going to see the compliant part. Yeah, I've talked about it already, but the FSA requires us to have clear processes for most of the things we do. So how do you release some software? How do you access user data? Yada, yada. We need to have processes, documents explaining why and how, and we need to have audit logs of what is going on. Who did actually use these processes? Yeah, we've been over that. The manual tasks. We cannot have anybody sitting at a desk granting access to anything. We don't want access managers, and yeah, we need to move faster than that, and we need to use the resources we have, the employees we have, to do a better job than just sitting doing robot stamps on something. So we need to ensure that there are absolutely no manual tasks involved in creating a new database. Say, of course, you need a manual thing like, I need a database in the first place. That is something that the developer puts out. But from there on to the database is ready for them to use, there should be no manual tasks involved. And last but not least, stay productive and keep moving forward. We need to keep working, we need to deliver features, and we need to not pay that much attention of getting something as trivial as a database up and running. That should be the least of our problems. And one important point here is that developers are lazy. We all are. If there's an easier way to do something that circumvents the processes, we need to do that. We need to fix that. We need to make everything we do easier than the wrong ways to do it. So, to this point, I'm just going to remark that we are using the Google Suite, the G Suite, to authenticate to our Kubernetes clusters already. And one of the ways that we could keep access to databases easy for our developers is to reuse the same ways of logging into a cluster, is logging into a database, or logging into the Gmail app. We need to, if we can align on the same mechanisms, it's known to developers. They need to know one thing, and they can use the same passwords and the same flows for everything. We'll get back to that part. So that leaves us with a couple of functional requirements, and probably a lot more. And yeah, these are the ones that I thought about when doing these talks. These were the main points that we needed to fix when we started looking into this. We need a way to create databases. We need to create roles for these applications. As I said, we're using Postgres. How many is unfamiliar with Postgres? To some. All right. That's it's probably the same as most other database systems, but we got a role system that grants you access to different things, and roles can inherit other roles and all sorts of crazy things. So we need a way to create a role that application services can use to actually access the database in the first place. So that's the application side of it. Then we also need some roles to access the database from the developer's perspective. So say I want access to the user database, there should be some roles in there that grants me that right. Then we need some granular access requirements, so we need to do this on each and every one of the databases. So it's not you got access to everything or nothing. You should be able to get access to a single database or a single schema in that database and something like that. And last but not least, we need to use AWS's IAM authentication mechanisms. That's regarding the G Suite implementation. AWS, it's a hosted Postgres instance, or it's hosted Postgres instances we use, and that means it's fairly integrated with IAM, that is AWS's authentication solution. So if we can make it work with IAM, it should be able to work with the G Suite as well. So we'll get back to that as well. But those were the functional requirements. If we could solve this, we would take off all the manual tasks that developers are using. We would take out some of the insecure processes that we have today. No reused passwords, no passwords on sticker notes and something like that. We could make it easier for developers to get a new database. And in this process, we also make the FSA happy because it's clear how does a database get created, how does somebody get granted access to this. So, moving on to the fun part, the implementation. So, as we are a cloud-native shop, we already got a Kubernetes system running. That is, we got Kubernetes clusters. We are used to thinking about resources. You got a question?
Yeah, I just want to ask, when you say database, what do you actually mean? Because you also mentioned an instance. So are you talking about creating database on the one single instance you have, or are you also creating instances?
Yeah, all right. The question was what I mean by databases and instances. Yeah, sure. We are talking about databases on instances, and we are automating the creation of databases on instances. We do not automate instances in itself. So these are managed by AWS in RDS, and we can create them with Terraform or whatever tool we like, but we do not take responsibility of creating the instances in the first place. That is outside the scope of this, and managed by the platform team at Lunar. That is me and Casper. And Emil. Yeah. So, yeah. Did that clear it?
Yeah.
Yeah, great. So, good question. Thanks. As I said, we're a cloud-native shop, and we have Kubernetes running, so the obvious choice for us was to use operators. That is Kubernetes operators. And just taken out of the Kubernetes documentation, I'll just cite this. Operators are software extensions to Kubernetes that make use of custom resources to manage applications and their components. How many of you are unfamiliar with the operator pattern or custom resources and stuff like that? All right, quite a few. I'll try to keep it introductory. So please raise your hand if something is unclear, so we can fix that. Yeah. So operators. Just to find out how popular this is, I searched for topics including the operator name, and there was 381 public repositories available at the time I took the screenshot. There is some confusion around operators versus controllers. The Kubernetes own components are called controllers for most things. So just to highlight these, controllers to the left, they reconcile state. Let's say a deployment got the controller manager that's I forgot the name. I'll come back to that. All right, it reconciles state, so you got a desired state and you got the actual state, and try to reconcile these things and make sure that the desired state is actually what we get. Furthermore, it interacts with the Kubernetes API to find out what is the desired state. That's what's stored in etcd. Operators, on the other hand, is the same. but it adds 2 points. And to be honest, there is a lot of confusion about what is what here. Operators versus controllers, and people use these interchangeably. So to me, at least, operators is extending the Kubernetes API instead of just using the existing resources. And it probably contains a bit more domain logic. Let's say a MySQL operator that spins up instances of MySQL in the cluster. Well, it knows something about how do you do rollouts of new versions and manage these states and so forth. So it's a bit more about the domain than just, is there two? No, there isn't, so add another one or something like that. But yeah, people use them interchangeably, and yeah, as we're gonna see, we used the wrong word for our controller, operator, according to these slides, so bear with me. And if anybody got some clear definitions, please come up afterwards and enlighten me. Yeah, so just to recap, reconciliation is what's, I think, one of the primary features of Kubernetes. That is, we got a desired state, we got some deployment that says we need 3 replicas of NGINX running, and then got the current state. There is no NGINX pods running. The deployment specifies the number and the template of the pods. And then the controller manager will try to say, all right, there is none, and I need 3, so I'll spin up 3 new pods. So that's basically just, it's a way of fixing undesired state and making it match the desired state. So in this case, that's a controller, according to my own definition of the controller. It uses pods, it uses deployments, it's native Kubernetes objects. What we did was to create an operator that's called a Postgres controller. Yeah. I thought about renaming this, but the GitHub repo is a controller, so that would just be odd. All right. Anyways, what we did here was we needed some resource, and as Kubernetes don't have any native database resources or database user resources, we need to have some custom resource definitions. So that's the document on the left. Then we got the controller. The document specifies the desired state. I need access to this database, and the controller will then make sure that that access is actually granted on the RDS databases, the database instances hosted by AWS. So this makes it possible to get access to things, but as I just spent around 10 minutes talking about compliance, this doesn't sound that compliant, because everybody can just add a new resource to etcd, and this controller will add them to the database. So hey, I'll need access to all the users' tokens. Yeah, that sounds good. No, so we need something more than this, but it's a foundation. So that's a little blob on the right, and then all the compliance parts, almost. We are using GitOps for deployment at Lunar. That is, every resource that the Kubernetes clusters hold are committed into a Git repository. That's the thing in the middle, the config repository. So as you can see, there's a component inside the cluster called Flux that will reconcile, again, what is in the Git repository and what is currently in etcd. So that's the part where that is how we get resources into the cluster in the first place. Then we need some way to put things into the config repository, and that is done through Jenkins in our CI pipelines. That is moving on to a specific access repository. So just to sum it up, a developer at the far left needs access to a user database. So he will write a custom resource that says, I want a Postgres user, my name is this, and I want access to this database with this reason. That'll be put in a pull request. Some peer in the organization will say, that sounds like a good reason. You got a support ticket, that's all good. He'll approve this, it'll get merged, and also released into the environments that's applicable through CI. auto release in these terms is the resource is committed into the config repository for the given environment. So it says it's a production environment, and we just commit this resource into the config repository for the production environment, and Flux will reconcile this, put it into etcd. The Postgres controller will reconcile what's in etcd and will set up the roles in the database. That's simple, right? Question?
How is that different from someone handing a form to some guy who then approves it?
Technology is the difference.
Okay.
The main thing about the question was how it was different from a guy stamping a document is there's no manual tasks involved here. There's someone approving the PR. That is the manual task. That's the audit part. We need someone to say, you got a good reason for this.
But isn't that the same as putting the stamp down?
Yeah, it is. But this could be anybody. This is not a guy whose only job is to approve pull requests. Oh, that would be horrible. No, it's anybody. So a team member or a manager or somebody, say I'm working late at night and somebody else is working remotely late at night, great, that guy will do it. Or so there's no one person doing this, and that's why it's a peer and not a manager or some sort. So that's how we go about it. But yeah, sure, we still need review. We need to understand that you got a good reason for these, after all. So that actually brings me to the red parts, the red text. And you are not really able to read that, aren't you? Anyways, we got 4 places where audit kicks in here, again, to keep the FSA happy. The first one is the PR. So you got a peer reviewing your request that is committed into this repository. So you got a git log with signed commits that says this guy needs access to this database and somebody reviewed this. That is signed and committed. So we got a git log here saying all changes to access requests are stored here. Then again, in the config repository, these are more Kubernetes close resources. Say we could use some templating on the left side in the access repository, but when it comes to the config repository, that is the raw YAML configuration. So there's another audit log. It's noisy because there's all the other deployments, but it's there, and you can see when did some change go out to the given environment. There's a time gap here from somebody approves the PR to that is merged. The CI has built it, validated the resources, and pushed it into the config repository. So that is why the 2 audit tracks are interesting to keep. Then we go into the cluster. The Postgres controller in itself keeps an audit track. So it will log every change it does to every resource, why it did it, and what resource it was, and what it did to it. So it's revoking some access, or it's granting some access to a database. So that is just the log of all the changes that comes through. And then last but not least, and really the most important audit track, is the one from the database itself. So we got audit logging enabled in the Postgres instances. That is, every query done on these roles are stored in logs and pushed into a Humio instance. So we track all the changes, all the queries you execute is stored for later review. So that means when the FSA comes and say, why did this user have access to this data? We can look into the config access repository and say, all right, the reason was this support ticket. You can say, why was my money gone? Somebody updated the balance negatively. All right, we can look at the query logs and see, well, this user did this. And why did this user have access? We can follow back to the original request and say, well, it was based on support ticket that said the balance was wrong. And we got everything nice and easy, at least to the FSA requirements. That's another question.
So aren't you missing an audit of the Jenkins? And I just hardcode my user into the Jenkins pipeline, and then I always have access.
Hardcode the user.
Like you're saying that the Jenkins pipeline is triggered by the PR request.
Yes.
Who audits the changes made to that Jenkins pipeline? CI.
There is no changes to the pipeline itself.
It's not something you have built up and some scripts or some third-party things.
No, to be honest, the access repository is the raw YAML, and then there's a couple of verification steps. That's the CI part. Yeah, so it'll just do some static analysis saying there has to be a reason here, otherwise there's no need to push it into the cluster and all that. Just makes static analysis, making sure everything looks good, and it'll commit it to the config repository. That's it. There's nothing in between here. There could be some templating, something going on, and then of course that needs to be audited as well. But every code change in Lunar is already required to be audited, so reviewed by someone else. So at least there's 2 peers to every change on everything. Oh, more questions. Time is running out. Yeah.
I heard it as, can I make a pull request to the pipeline repo, the repo with the pipeline code?
Yes, you can. You can make a pull request, and somebody has to
circumvent the...
Yeah, but then you gotta be 2 guys or 2 girls or a guy and a girl. I don't know. But you need to be more than 1 developer. You need to keep these things in. And for the more critical parts, often it's somebody who owns it, or so let's say we own the platform team and got some critical integrations that, let's say this pipeline script, it has to be audited between us in the platform team, and if somebody else makes a PR, it also has to be audited by us. So there's some limits to what you can do. But of course, nothing is bulletproof, I guess. All right, let's move on. That was the audit trail. Let's see if I can keep track of this. Another diagram. I talked about G Suite earlier, and for those who knows Postgres roles, if I add a role in the Postgres instance or the database, that doesn't really make the developer able to log into anything. There needs to be something else here. So what we do is we facilitate AWS's IAM service. So a developer contacts G Suite and does a single sign-on to AWS. That gives them an STS token. That means they can get specific tokens in AWS to do stuff on AWS, if that makes sense. Specifically, it grants them the rights to generate these DB auth tokens. That is some time-limited tokens that can be used to passwords when connecting to the database. That means you authenticate to G Suite, you get a lease to be able to request these tokens. You can then use that token to, say, use PSQL or some other database UI you want, and connect directly to the RDS instances. So that is what AWS provides. They can authorize who can connect to the database, not what can you see on the database, what databases on the instance. Oh, sorry, let me be clear. You can connect to the instances, but it doesn't tell you anything about what resources on the instances can you interact with. Can you update a record, or can you delete a query, or truncate, or drop a table, or something like that. That's where our component comes in. That gives you the additional grants that makes it possible to, say, query and select some rows from the user database or something. So that's the part. So in practice, all this is just another role in the Postgres database. It's called RDS IAM. So when you authenticate through this, you get granted this role, and that makes it possible for us to grant you additional roles, and you can sign into the database. It's a bit convoluted, but I thought I'd bring it here, at least for reference. Yeah, we're in the section of implementing, and we still haven't implemented anything, but we have thought about things. So let's begin to talk about operators, shall we? Time is running out. Yeah, operators. There's plenty of options of creating operators, frameworks and such. I've brought the three operator patterns, SDKs or frameworks that we considered when we looked into this. But there's come plenty since. Look it up. There's all kinds of fun ways to create operators, from simple webhooks to the operator SDK that we use. That is very centric around building the application yourself. So the operator SDK is built by Core OS, and that is the company that also coined the operator term initially. They provide this SDK that brings you some high-level abstractions. You don't have to interact that much with the client Go library. It provides some scaffolding, code generation. Say you got a resource, it'll provide you all the schema validations for Kubernetes and such. For day 2 operations, they provide the operator lifecycle manager. That is a component that is great when you got, say, an operator running MySQL instances, and you got 100 MySQL instances running in your cluster, and you need to upgrade the versions. So that's around how do you update versions of the operator itself and so forth. That is great. And just a great resource for learning more. They got an awesome operators repository and the official operator framework GitHub organization, and it got currently 138 operators listed there. So all things from MySQL to etcd cluster operators and yeah, all kinds of fun things. So take a look there if you need inspiration of what you can do with an operator, and maybe also something you shouldn't do with an operator, I guess. The other option is Kube Builder. It's much like the operator SDK. It's built by the special interest group of Kubernetes called the API Machinery. They are the ones maintaining the underlying lib that the operator SDK is also using the controller runtime. So it's pretty much the same logic and the same APIs you can interact with, but they put a bit another of an abstraction to the code generation and such on top of it. They also support admission and custom resource conversion webhooks that the operator SDK does not support that. So if you want to create admission webhooks and such, this is a great thing to use. And last but not least, the sample controller. It's a copy to your destination and rename things. It is literally a sample of how does Kubernetes think controllers should look like, and it's what their own controllers are based off. So there's no tooling here. There's no auto upgrades, no code generation, no things like that. It's just copy this project, rename it, and start from there. It's reference implementation, but still great, and maintained by the same SIG API machinery. Yeah. So custom resource. Let's look at YAML. Yeah. Now it gets interesting, right? Yeah. That's 40 minutes in before the first YAML. That's impressive. All right. So as I said, we got a concern around databases, and we got a concern about users. This is the custom resource, an example of a resource of the database thing. Kind PostgreSQL database. That's an awesome name to put in kube control get post. Yeah. So what you see here is you got the usual metadata fields, and then you got a spec, much like you know it from all the other resources. So here I spec, I want a Cloud Native Nordics database. Its host value, so the instance that this database should be created on is postgrescloudnativenordics.com. And the password is pulled out of a secret called Cloud Native Nordics in the DB password. If you are familiar with deployments, you'll know you'll recognize the way of referencing values from other resources, say config maps and secrets and so forth. And that can be used in most of these. So this is what we try to say. From a developer perspective, I'm writing a new service, I need a database. This is all I care about. The password and the name and the host it should be put on. That's all I need. If I put this in within my service deployment, I can be sure there's a database available to me. That's the first thing. Then there's the user. And this is me, my initial Lunar ESO. What I'm asking here is I want some read permissions. That's an array, so I can have multiple of these. I use the special all databases true flag. It sounds hacky, and it is not. It's intentional, but what it says is for all the Postgres databases that you know, I want read access. It's great for development environments where you don't need specific rights. There's no confidential data. Everybody can read everything. There's also a specific database field, and we'll get back to that, that can use the granularity that we need in production systems. So here I'm saying I want access to all the databases you know on the same host as the database we just saw, and I got a great reason for that. So when you're using the operator SDK, you're using Go. and you're writing structs to represent these custom resources. Can you read this? Great. Some question? Yeah.
I have a question about the previous slide.
Yeah. This one.
Why not go for something like RBAC definitions and reference your CRD and say CRD like Postgres database X read write whatever, you know?
Yeah, we could do that, but this to us was simpler for our developers to look into.
Okay.
Just be honest. Yeah, it was simple enough, but covered our needs. Maybe down the line we'll regret that and use a more sophisticated setup, and then we'll migrate and have a headache. That's how it is. Yeah, if that's an answer. Yeah. Yes. So as I said, we're defining Go structs. So here we got the user spec, we got the name, and got a read and a write slice. That's array in YAML. And as you can see, we got the host field that was required. I don't know if you actually can see anything up here. There's a host here. Then we got the all databases Boolean. Got a database resource var that is a reference to, say, a hard-coded value or a config map or a secret with these keys in. Same goes with the schema. You got a reason that's required as well. And then you got a start and stop time. And that's a little twist on this. If you ask write access to a database for a support ticket, we don't want you to remember to revoke this access when you're done with the ticket. So instead, you put in a stop, say, well, for the rest of the day, I need write access to fix this issue, and then it'll automatically be revoked after that time. And you can do the same for the start and say, on Monday, I need access to this, but I'm just preparing to take up this task or something like that. So you define these structs, you run an operator SDK command, it'll generate one hell of a lot of YAML and some validation, schema validations. As you can see, there's some annotations like /s plus optional, and that'll be translated into OpenAPI validations. So when you try to run kube-control create PostgreSQL user, it'll do some initial validation right up front. There's all sorts of keywords you can use here. And this is the whole reconcile function with a couple of details omitted. I should have picked another background. The essence is really, when you use the operator SDK, you implement a reconcile function, a method. You'll get a request object that is enough for you to uniquely identify the resource in the Kubernetes APIs. You'll fetch this API first thing, and you'll decide what to do from here. The most important things from here is that everything you do has to be idempotent. That is, if you see this twice, you should have the exactly same outcome. If you get interrupted in the middle and you see the resource again, you should be able to reconcile that bug or fix the intermediate states that you have created. So say I got the service, I got the database created, but I didn't get to creating the role before this pod was terminated. Next time I start up, I get the same request in, and I should just keep on working. So say, oh, I need to create the database. Oh, it's already there. Great, moving on. So it has to be idempotent. You're going to see requests multiple times for the same resources, and you never know what changed. That's important. So just do everything you need to do every time you see the resource, and it'll work great. I've omitted some details about this. Only ensures the Postgres roles. That is, I'm setting up the roles that need to be set up, but I don't do anything about IAM. We also do a hook into AWS regarding the IAM roles, making sure that I can actually connect to these systems. The source code is available. It's open source in a LunarWay organization at GitHub, and I'll link to it at the end, so you can look into more details if you're interested. And now it's time for a demo, and my time is out. It's fine. I'm gonna try to do this quickly. And whenever you try to do a demo quickly, it's gonna not work. So first I need to show you the screen, and I'm just gonna see if, oh, no, that's not what I want. See if I can mirror these screens. There we are, mirror. So you can see the terminal? Yes. And I can see the terminal. That's great. That's not the word. All right. So I'm just going to show you just briefly the operator in action in a local cluster, a kind cluster. I just started it before the talk started. So I'm going to watch for resources. I'm going to watch for pods, PostgreSQL databases, and PostgreSQL users. And as I start this, I'm getting an error that says, I don't know the resource type PostgreSQL. I haven't started in it. It's a completely empty cluster. The custom resource definition is not in the cluster yet, so I can't see anything about this. So, yeah, and is the font big enough? It's okay. Great. And we're going to move on to this screen, and I'm going to follow my guides here, and I'm going to call make resources. What this does is it's going to create RBAC service accounts. It's actually ready for the Postgres controller to be deployed inside the cluster. We're not going to do this in the demo. I'm just going to run it locally connected to the cluster. Then it's creating the custom resource definitions for both the database and for the users. And if everything is well, we should, and it's creating a PostgreSQL instance running in a pod here. So now the watch is working. I don't get an error. It knows the resources. There's none of them, but it knows them. And we can see the pod is starting up. It's a PostgreSQL 11 instance. I'm just going to wait and see if it starts. And then we're going to try to create a resource in it. Waiting, waiting, waiting. Yeah, great. 60 seconds. All right. I should have a joke. Yeah, loading bar. Really. I'm 10% done with creating this Postgres instance.
I have a question.
Yes, please.
What was the challenge of making it resilient of restarting? Like you said, if this time the job created the database but didn't create a row, the next time the job should be able to execute the same and they should create the same result. But that comes out of the box with Postgres.
Yeah, but the difference is if I try to create a database, say I'm running create database in Postgres, the libraries, the client libraries will give me an error. And the important part here is to differentiate this error from the database that already exists, and I can't connect to the instance, something like that. So it's not, I don't have to know, Postgres gives me a lot of these, and actually what we do is we try to create the roles, we try to create the database, we identify the errors that we get returned and say, is this something that's okay, it's expected, say the database already exists. If that's the case, then it's great, return no errors, because that's expected behavior. If you just say, run this query and return the errors, then you're gonna stop the loop every time. So it's not that you have to take it into account, especially the important part is that you shouldn't insert things or you just shouldn't drop things. You should always update or insert things.
But what do you insert when you just create a role?
Yeah, in this case, it's not important, but it's more general observation of writing operators. You need to be aware of everything you do here has to be, let's say you're writing a DNS operator and you create DNS records in AWS based on some resources. If you see the same resource multiple times, you don't want to put in multiple resources in DNS records.
So it should be functional.
Function.
Like functional programming.
Yeah, it could be. Yeah, well, it's just the nature of being idempotent. However you put it is I guess fine. And it's very domain specific when something is okay to continue with and when something's not. I hope it answers the question. I can show the code afterwards if you want to know the specifics of this this idempotency handling. Yeah. All right. The Postgres instance started, and I'm just gonna move to a small font screen and forward the Postgres instance to my local machine. It's just a kube control port forward, and it's not important, or it is. But so here we're gonna, I think we're gonna try to create the database. I got a YAML here, much like the one I showed earlier. It says I want a cloud-native database. It's on the host PostgreSQL, and it's got the amazing password. The password here is for the applications to use and not for the developers. So I'm just going to apply this, kubectl apply f demo database. And if we go back to the watch, we'll see, hey, the resource is created. So far, the controller is not running. So as you can see, there is no status here. There's nothing updated. There's no host information. This is just the resource is put into etcd. No one has done anything about it. It's just, it exists. That's a bit boring. So let's try to see if we can start the controller. And that is a great command here. Yeah. So basically, I'm compiling the source. I'm running the main function. I got a couple of flags indicating what credentials should be used. To create new roles, you need some user on the database to create new roles. So here I'm using the IAM creator role. That's the admin password of this pod that I started. In production environments, these should be specific roles created just for this. So I'm just going to try and start the controller, and hopefully we're going to see some logs. And we saw a lot of logs. The intention here is, as the controller starts, get all the resources in etcd. And so it should have gotten the database resource we just created. And if we move back to the watcher, we can see that now there is a running status, and it's been updated. So, in other words, the controller has seen the resource, it has created the database in this complete empty instance, and that is great. So let's see if we can get access to it. Let's see, we got a demo user YAML here. Again, much like the one we saw just before, I want to create a BSO user. It's on the same host as we just saw, and want read access to all the databases in this. Currently, there's only one, so that'll be that. I'm also specifying that I want write access to a specific database. It's the same, so that's great. Let's apply this. kubectl apply fdemo user. So back to the watcher, we can see the resource is in etcd, and if we jump to the logs, we should see a blob here. This is the important part. We see it. The first thing the reconciliation loop does is print out, I'm starting to reconcile this resource. Then it's connecting to the database. That went well. It's creating the role. It's granting me read access to the database, and it's granting me read-write access to the database. We made a concern about whether it would make sense to only allow writes, but you probably most often want to see the data before you write to the data, so it's a read-write role when you ask for writes. So with this in place, I should be able to sign into this database. And just for the sake of it, we don't got IAM in this setup. It's just I got the role set up. So if I run PSQL, I want to connect to the local host, the cloud-native database. That's the one we just created, and I'm connecting to BSO. That's the database user. And we watch what are the users in this database. We can see that my user is there, BSO. As lucky as I just signed in with it. We got the cloud-native user. That's the one used by the services, say the application that's in need of this database. And then we got two roles for the read and for the read-write that is created with the database. And those are the roles that are granted to my role when I ask for permissions to get these things. As you can see over here, I'm a member of these two roles. Yeah, so if I remove the read, now we are running out of time, so maybe I shouldn't show it. But if I remove the write section from the YAML and apply that to Kubernetes, I should see that this read-write role would be taken away. But you get the sense, I hope. So that was it for the demo. And just last, I want to say thank you for your patience, and sorry for going over time. And hopefully there's some questions. And here's some links to the other Lunar blogs, talks, some open source, and the last one is the link directly to the source code of this controller. bear in mind it's under active development, and some of the features I've shown or talked about today are not actually implemented. So it'll be in the next couple of days or weeks or months, who knows. But yeah, that was it. Question?
I have a quick question. If
Yes.
someone deletes some of the things you made in passwords behind the back, will
Yes.
it then reconcile?
Yes. Yes. That's an important part of it. And there's some controllers, some operators does not do this, and some does. But the important part is, what do you want to watch the resources that you created on something after you created it initially? That is reconcile side effects from other systems. So if I go in and remove the role, I will not get notified. But instead, what we do is we got a daemon running in the controller that'll, in a fixed interval, will look for changes and reconcile and make sure everything is still in sync. So that works for this application. Yeah.
Awesome. Let's give him a big round of applause. I think that's food.
Yes.
Yes. Awesome. Follow him.
Yes. So we bought some sandwiches and some Coke, not Coke, but Coke. And it's over here. So
dag med Microsoft, hvor de var nogle repræsentanter fra dem, der repræsenterer tungreguleret industri, altså finansiel, law enforcement, juridisk, mega spændende. Kører I virkelig hele jeres bank i AWS? Det kører sikkert i en eller anden AWS region, men hvor kører det i det? I Irland? Så I kører en dansk bank i Irland? Crazy.
Det betyder, det går videre.
Okay, fordi det er nemlig noget, altså, vi har ting, som vi overvejer, du ved, Terraform har aldrig nogensinde lavet noget kundevendt online overhovedet. Vi bygger ligesom en dims og shipper den, og ellers må du ringe, ikke? Altså, men nu vi begynder at eksplorere den side, og folk tænker jo,
Må I se den baggrund? Må I se den baggrund?
Og alt, hvad der hedder almindelige.
Det er meget nice.
Man skal jo have et andet.
To stykker her.
Jeg er lidt skuffet over, man ikke ramme. Altså, her kan man ikke trykke. Det er først. Det er kun, når den er i live, man kan trykke i øjnene.
Ja, det kunne være. Godt lige at lave en eller anden fed feature der.
Skal man hoppe på noget wifi måske?
Eller gæst, der kommer.
Hvorfor ingen
Der er sådan noget mobil. Man kan skal bruge noget streaming service. Hvis vi bruger mobilen, det er ikke spændende.
Der var nogle vindue. Det er først rigtig blevet aktuelt med det.
skriver du også stort på flaget, at vi kan hoste en bank.
Ja, det er det.
Det der, jeg synes, det er hyggeligt på alle fronter. Så ekstremt fedt. Altså netop fordi, at vi lige hører godt lige måske, at jeg kom på Terraform, så det, alt for os er jo, det er jo godkendt. Altså alt, hvad vi gør, skal jo på den her slags cybersecurity front, skal jo godkendes af FE og Civil Cybersecurity og lige fra fronten helt op til. Og det er jo kun for de ting, som vi overhovedet må have på internetforbundne systemer. Kan man jo snakke om, når det bliver midtest, hvis vi siger. Så er der jo faktisk også vej igennem. Så koster lige et par 100.000 kroner i et stykke kryptokasse. Til at sikre forbindelsen.
Der er mange gode eksempler. Jeg ved, jeg har ikke lige hørt noget som her omkring militær, hvordan der er noget der. Jeg tror sgu også, det var rapport. Der er nok nogle lidt. Den amerikanske kort var bare on-prem. Det var der med Netflixen, og hvad med det kan de bare.
De er med Azure, så. Altså, Azure har bygget, de har bygget beliftelse tilbage. Jeg læste noget med Microsoft i. Ja. Og de har bygget 7 eller 11 datacenter til US government i Amerika.
Ja, det har AWS har også en hel region, der hedder Cloud.
For dem, det handler om, at de skal være uden for en 200 master i USA eller andet. Det er jo helt andre krav.
Flystyrsradio, så mere overkommeligt der i alle sødevis. Maks 5 km mellem datacenterne.
Spændende.
Det er virkelig nogle stikker.
Men I er forholdsvis åbne omkring jeres arkitektur og hvordan I gjorde. Det er vildt.
Altså, du vil nok finde de fleste detaljer. Der er selvfølgelig nogle områder, vi snakker.
Ja. Det kan godt være sådan på tech.com. Vi får se det endnu mere.
Men ikke så her, der ligger masser af ressourcer, både talks og kode. Og hvad vi ellers kan komme afsted med at bruge. Vi gør sådan som det her er udviklet fra starten, open source. Vi holder ikke på det, og så viser det senere. Vi skal jo udvikle det åbent, det kan være, der er nogen, der kommer til at det er stor tillid til, at det skaber mere sikkerhed for mange sikkerhed. Så længe man er åben om det.
Helt med på den tillid.
Men det er ikke altid government loyalitet.
Nej, men fedt. Hvad hedder det? Ja, fordi security by obscurity er bare en forkert tanke. Men på en eller anden måde er nogen, der finder det. Ja.
Hvis du prøver at kigge på, hvad white hat hacker finder, altså i Google for eksempel, du kan snifte så mange ting i flere år. Og selvom det er sikkert super det er lidt tid, du køber dig. Det skal gerne være andre ting.
Sidder I også i Aarhus, eller?
Ja, vi har kontor.
Hvad? Ja, I har nok også kontor i København.
Ja, vi har kontor i København og i Aarhus, Oslo og
Så er I alt i alt kun 100 mennesker?
Ja, lige over. Vi fordoblede sidste år.
Ja. Nej, jeg selv med det, det er en lidt rigtig mange mennesker. Har vi jo betalt for det.
Det er vi godt i gang med.
Cool. Tak for hjælp. Jeg tror det skulle være men det her med Postgres, det er i AWS. Hvorfor laver I det så ikke egentlig?
Sæler. Jeg kan give noget lyd. Jeg var det. Det var meget godt.
Hvor vil du have den hen?
Den der. Det kan man selv få med et eller andet sted.
Kan man lige få lov til. Jeg skal lade med at trække det ud af. Nå, den sidder rundt om.
Der. I sådan hul der.
Det er fordi, jeg vil lige have den her ud. Jesus Christ.
Det er noget billigt. Bare putte lidt om der.
Sådan der. Måske. Jeg står stille og venter.
Det ser godt ud, det bliver rigtig godt.
Kan man... ja, tak. Nu må vi se. Kan du ikke lige...
Du kan selv lige tage den, når du er klar. Jeg vil lige sige velkommen.
Kan du ikke lige se, om den sidder rigtigt? Den her, altså. Det er lige så meget det.
Den vej, sådan der.
Ja, fordi så spiser jeg den nærmest.
Og så bare tage den. Ja, det er da godt.
Det har jeg da ikke lyst til.
Jeg tror, det går. Se om der er hul igennem herovre. Okay. Awesome. I think we are ready to get started with the second talk. And our new co-organizer of Kubernetes Aarhus, Mike. So let's give him a big round of applause. Yeah.
Hello. All right. So today we're also not only going to talk about Kubernetes operators, but also Terraform, and more specifically around building custom providers. And we will also get through some more basic concepts before we dive into that. First of all, as mentioned before, I'm an infrastructure engineer at Humio, building out our hosted offering of Humio. And the last KubeCon, I met this random guy that had apparently a metal shield with the Kubernetes logo, which was quite interesting. Other things. I'll go to KubeCon Amsterdam as well. I know Cloud Native Nordics will also have a gathering Monday evening. So if you're there, I would encourage you to go. In my spare time, I do lots of networking related things, building an ISP. That's apparently something that you do in your spare time, and what I've done for close to 11 years in Odense for students. This is my meetup number 18, according to meetup.com, in this group, 10 of which were when I actually lived in Odense and had to drive 1.5 hours back afterwards. So the general agenda today will be basic stuff around Terraform, which we need to understand before we dive into the Terraform provider. And I will also need to briefly touch what Humio is in order to understand the example that we'll go through. So before we start, I'm definitely no Go expert. This is basically just me trying around with stuff and trying to figure out how stuff works, and I thought it would be nice to share it with you guys because it's, as you will see, it's really, really easy to at least get started. So first of all, at least when I started diving into Terraform, I had this idea of Terraform being able to do this magical thing where it understands the entire infrastructure and you can just lift and shift your entire thing from one provider to another before actually trying it out and understanding what it even is, which is not the case whatsoever. It does try to understand the resource dependencies, but it will never be able to fully understand what you're trying to do, but it'll do its best. And also, migrating existing things can quite often also be a pain. Some features are not really fully supported, such as the import functionality. For instance, the Helm provider currently does not really support that feature. I know there's activity on the PR that will do that, but it's not merged, so yeah. So
Terraform in itself is basically a way for you to write your infrastructure as code. You can do Git, or track it by Git, put it into your pipelines. It basically builds up this resource graph and then shows you the execution plan based on current state and what you have defined. Then you can figure out if you want to go ahead or not. And apparently they don't really list the fact that the many providers that they support, because apparently they think, or they assume that many people know that already, but I think that's one of the main key features as well. They actually do have 125 official support providers. I've only used 10% of them so far. There's even more community-built providers that are listed on the official website, but not supported by HashiCorp. You can also find others that are not even listed on the site. But basically, Terraform is sort of split into a few bigger concepts, being these data sources and resources. Data sources is basically, as it indicates, a way to grab data, which you can then use to configure your stuff. Whereas resources is typically seen as some sort of action that is actually being done and not only fetching data. Typically, there's these many different meta arguments you can see, such as depends on. That's a way to explicitly state the dependency yourself if it doesn't do that by itself. I mean, based on the resource graph. You can do lots of other things like count and for each and stuff to basically do loops to do many resources. But it boils down to a resource having arguments, resources and data sources having arguments that you can put into it, and then you can access that as well as some additional, potentially additional attributes. Yeah, and you can cross-reference the resources or the fields of different providers, or resources from different providers. So basic example, we define that we want to leverage this AWS provider. We create a zone to hold the DNS record, and then we can define the zone ID where we references the zone ID of the zone, which is one of these exported attributes. Basic example. So in order to make that happen, you would have to simply run init. Then it finds the provider that you need to do whatever you're trying to do. Then you can run plan. It will show what's the plan, what is it going to do. You can also run apply, which either takes the directory in or the plan from before, and will then execute that if it's told to, and then you, of course, can destroy stuff again. Brief example, as before, showing what it will show if you try to find those two resources. Typically, really easy to see unless you do complicated things, which you quite often do with tons of resources, and it can be a pain. But basically, all of this requires you to, or the provider needs to do or take some action. And in order to make the desired state happen, it needs to use this state file, or this state, to understand how it actually goes from current state to the desired state, much like reconciliation as before, but this is more of a one-off thing. Typically, it's just unencrypted JSON file named terraform.tfstate on your machine if you don't really specify that you want it stored remotely, but you should do that. It's important to not lose it because it's a pain to recreate. It's getting locked when you do any executions in order to prevent multiple parties doing changes on the same things. Yeah, and last part is that the provider's resource, they access this resource when we get to it later as simply it's this empty interface type. So you need to tell it which types the
data that you store in it is of. In case you are new to it, this lifecycle prevent destroy feature is really handy, so you don't mess it up and for whatever reason delete something that's important to you. tflog, the environment variable, is really easy to use as well, and will give you a lot of insights to what the provider is doing along the way when you run Terraform. That's one of the ways I figured out that apparently my AWS credentials expired while running a command. And then modules, you can build them yourself. Some providers, because they're so complex, like AWS, provide their own modules to encapsulate a bunch of different things, and they can also be nice to know about and build yourself. So some stuff to at least watch out for. Provider and module version compatibility is a big one. From Helm, for the new Helm provider, for instance, they totally switched from Helm version 2 to version 3, which is very different for those of you who know Helm. And then there's some gotchas around modules. They're not really treated as the same as the resources. You cannot, at the moment, do depends on and stuff like that, and counts don't also work, so yeah, be aware of that. And then you can make it really ugly and complicated for people to read, but I would encourage you to try to make it as simple as possible for your colleagues as well to be able to review your changes. So state divergence is also something that's important. Don't go in deleting, changing, or creating stuff manually. Again, it's all based on this. We have this state, and it's going to act on that. So if it doesn't have the correct state, it will fail. You can import some stuff, as mentioned before, but it doesn't always work that well because some resources don't really support it and stuff like that. In some cases, if you, for instance, delete a resource at the cloud provider, you also need to update the state, because if not, then Terraform will try to delete something that doesn't exist. So then you may need to go in manually, delete the thing from the state file. But I would at least be careful when doing that, because again, state is important, and you can easily mess it up. And doing refactoring, because of doing those state modifications by hand is so complicated, it can also be a mess to do. There's also the fact that when doing state logging, it can take some time to actually run the command. So if you have multiple things doing stuff at once, it's a pain to log the state and have it logged for an extended period of time. So it can be a really nice thing to split up the state so people can work in parallel. Some of the tools that we use, Terraform is one of the tools for helping us with role switching across different AWS accounts. Also helping us with splitting this state up such that we don't all essentially try to lock the same giant state all at the same time. The proxy, it's basically just easier to debug some of the things related to the provider, which we'll see later. And the last one is just an easy way to keep my things such as environment variables out of my files, because you really don't want to put in your API tokens directly into your Terraform code. And when testing, it's easier to just use something like this. So, I mean, enough about Terraform basic stuff. I want to talk about how we can build our own. So at Humio, we run a log management solution that we host for customers. So it's important for us that our hosted version works, because if not, we cannot really receive. the logs for customers, and also people cannot really search in the logs, which is also troublesome. So we use this thing called Checkly, which both for it, and it uses this Terraform plugin SDK, and it's built in Go as basically everything else. But it was missing one key feature for us, because Checkly by default, when you configure it with the API, it assumes that you only see stuff as degraded after 15 seconds of timeout, which is way too much for us. So I wanted to set it a little bit lower. It turns out that Checkly didn't really support that feature. But after mail to the guy at Checkly, Tim, he basically exposed that feature within a few hours. Pretty nice. And then I just wanted to add the feature to the provider. In doing so, I saw the structure of the project and how it was built, and I thought, wonder what it would take for me to actually do my own for Humio, because we also, we monitor Humio with Humio, and much of the data. We do also use third parties, but the majority of it is in Humio itself, and this is where we just briefly want to touch. So what are we gonna see, at least for the demo stuff later? So Humio is basically this thing. I won't go into details or bore you with all the details, but you have servers running logging agents. They send us the log lines to the ingest part of Humio. At that point in time, Humio will try to parse the logs to understand the structure of it, if any, which makes it easier for people to later on consume the logs and don't have to write really complex queries to make basic sense of them. And this is where we're gonna see the demo later. Because these parsing of logs can be very complicated because, as many people may know, logs differ quite a bit in their formats. And just wanted to touch on the why I even do this Terraform thing. Not everyone uses Kubernetes. Many people do, but we also have the hosted offering, and Terraform is basically all over the place. We use it ourselves, and we basically also wanted to use it. And this also works for our customers on both on-prem and the Humio cloud. And also the fact that we already had a CLI client written in Go, so we already were almost there. So I started with building these parsers and also alerts, notifiers, ingest tokens, which we're not going to go through, but parsers specifically, that's what we're going to see. Log lines, very different, but the idea is that all these essentially are shipped with the same token, so sure, you can tag it and stuff like that, and you probably should, but you still need to extract the different fields to make it easily searchable afterwards. And this is one of our parsers, really short. I've seen longer. It's not important that you understand it. It's just, it's gonna be a pain if I had to recreate it. So it would be nice with stuff like this if we could just put it into Terraform, and then we at least have it in Git, and everything is tracked. So let's do that. So there's 3 major concepts that we're gonna look at. First of all, you need to, we're gonna use the plugin SDK that Terraform provides. And they have this provider, and then a resource, and then there's a schema that we also need to take a look at. And the stuff on your right I've not actually used, so ignore whatever's on the right. It's just to give you a feel for where I'm at and what is possible. So on the left, when the provider is initiated or created, it runs this configure func where you can define what it should do, such as configuring or grabbing stuff from environment variables, if that's a way that you can provide credentials to your provider. And then you can use that to return a client that you can later on use to communicate with the API. I'll show it later. And then there's these, you can define data sources. You can also define resources where you simply put in, this is the name of the thing, and then the whole resource definition, which we'll see soon. And then there's a schema where you define the attributes and the exported fields for the provider itself, not the resources, but the provider itself in this case. And basically, the same for resources. You also have the schema defining the resource, the attributes and arguments. And then you define these functions, which is basically just what should, based on the current state, if it doesn't exist, first of all, it needs to know how can it check if it exists. You have this exist function for stuff like that. You can also, you need to define what does it need to do to create the function. You implement it as the create func and vice versa. The schema is basically the whole, the largest part of it, besides the actual implementation, because there's a ton of, it's quite verbose. But you need to define, is this specific argument required, optional, or whatever? Is it a list? Is it a string? Is it a number? If it's the list, what are the elements in the list? Which type are they? How many elements do you allow? And stuff like that. If you change it, should it force create a new one? Meaning that it will delete the old one, then create the new one. You also have the option to define default values if something is optional, either by simply specifying it or specifying a function that can calculate it. And now we'll see a bit of code and hopefully, maybe, no? Can you read it? Yes? No reaction, okay. But basically here we see that we have this configure func. I use, as mentioned before, the Go client we already had from the other project. Instantiate that, return the client, so we can use it later on. Define a parser type, a resource type, and then this is the function that implements that. And then currently it only allows the address of the Humio endpoints and then the token that should be used. One of which is required and sensitive, but the other one is will default to our cloud offering or hosted offering. And the resource for the parser basically looks like this. We have these functions, which we'll see soon, and then there's a schema where in Humio, data is organized into repositories. So when you send data, it ends up in that repository after being parsed. So we also need to define which repository is it, what are the name of the parser, and what should it do. Then these are some of the functions to actually do this. Based on this resource data, which is what is defined in the actual resource, so you can see we had this name and repository and stuff like that. You can then say, okay, now from that resource data, I can grab the repository and then pass it into the library that we already used for our CLI tool. And then you, as many other things in Terraform, you need an ID for the resource, which is something you also need to set. Maybe I shouldn't use name, but I mean, it's still early days, and we do require you to have unique names. And then a way to also based on the data that is coming back from Humio, need to sort of take that data and put it into the state. That's the idea with that. So you have some sort of like mappings from, in this case, our the Golang client we have takes a parser object, not just simple strings. So I need to create this parser and just need to build these functions that can then convert a parser to what that is represented in the state file, and then the other way around as well. And there's a bit more stuff here, like the tag fields and tag data, which I just removed from the other slide for simplicity. And when you then need to install it, there's a naming convention. You basically just suffix with the provider name. There's specific folders that you need to put it in. And then when you run Terraform init, it will be able to find your plugin. And I just wanted to at least show that what I have works. So locally, I run an instance of Humio, and then the idea is that you can then the main function is super simple. It simply just serves the plugin the provider. This basically is basically what you saw before, but there's a few extra resources, as I mentioned before, and some extra validation. And then the parser itself, basically the same. There's a bit more to it. So given that this thing works, so we have Humio running here. This is the current list of parsers, which many of them are built in, and Humio in this specific repository will create this by default, which is why it's there. We can then go in and we can, I've created an examples directory, we can build the provider in it, where it knows about where the output is. It's a bit long of a line, but the idea is that we do what I mentioned. We build it, we init, we do apply. And if we do that, we see in the beginning, very long, it builds this graph of the resources to understand if there's any dependencies and stuff like that that it needs to take care of. And then it prints this very long plan for what it's going to do, create alert, parsers, whatnot. So let's just do that. And now it created a bunch of stuff, and inside the Humio we can now see that all these parsers exist, and then we can see that example from before. I have this parser from the slide, and we also support adding some sample data, because if you change something, you probably want to know if you broke your parser or not. So that's also tracked in the same Git file, or the file in Git. And when you then, from a user perspective, want to take a look at that specific one, here it is, called webfront. There's some sample log lines, and then the script itself, and apparently VS Code doesn't understand that we can actually, this is not a comment, but anyhow, so that's sort of how you use it. From a user perspective, what happens when you create it, and then it pops up, and you can obviously delete stuff as well. And you can do emojis if that's a way you want to parse your logs. If there's fire in your logs, then it's an error. If happy face, then probably not. So obviously, we also want to make sure that it can actually delete all the stuff again, which it hopefully did. And yes, it did. So this wasn't really a deep dive. This was basically just me toying around with it and wanted to share that it's actually really, really simple to get started. The official documentation is really, really nice. And I can only encourage you guys to, girls, to take a look at it if you have some use case, if there's not a provider for whatever you're looking at. And I mean, another benefit, the last point here, is that it's not so scary to take a look at other providers. I had this weird case with the AWS provider. Now, often the convention is that every resource has its own file in the implementation. So you just find the file called whatever resource you're looking at, and then you'll be able to see the code and find what it does it do when it updates this resource to easily understand what went wrong or happening. So yeah, so the resources, I would probably start, if you're gonna do build your own, the official documentation combined with the plugin SDK that they provide is excellent. And for me, I used the Checkly provider as a starting point initially, and as well as the API package we have in our CLI tool, and then lastly the repo for the current state of the project that I demoed. So yeah, thank you.
Questions?
Yes.
Yeah, okay. So if I understand correctly, you already had a Humio tool that would kind of do all the hard work that you're using in-house, and then you kind of...
Yeah, so the question is what we had before, basically what I started based on. We have this Humio CTL tool where we have a specific external package which defines sort of the Go client for interacting with Humio. And the nice thing with that is that the smart people that did that pulled it out in the very start, in the beginning, so it's already a separate thing, so I can simply just reuse all of it from here. There were certain things that weren't really supported in terms of the alerts and stuff like that, but that was just added to the CLI and the API defined in there, and then I could use that. Any more questions? Behind you, yeah.
So just to be clear, what exactly did that provider you made do? Did it start some instances on a server somewhere, or what exactly did it provision?
Yeah, so basically it's just a wrapper, but no, it didn't really start a server. In this case, Humio, the software is already running, and it's more of a how do I configure Humio to be and understand the logs that I'm gonna send to it, such as the passing of logs, and if you have alerts defined, you also want to keep track of that so you don't throw it all away and lose it. So it's basically just a simple wrapper between the Humio Terraform, or the Terraform code, and then Humio's API. So you can define all of it in Terraform and cross-reference stuff, where if you use PagerDuty, you can grab the token with their provider, and then you can input it to the notifier in Humio, so you get your alerts. It's really nice that you can sort of cross-reference across providers. Yeah, again?
So just for me to understand, so what kind of thing is it? So it's a way for people who are using Terraform to interact with your API?
With our product, yeah.
Okay.
Yes. Yes?
So the next thing you're building is an operator.
Yeah, you would like that, wouldn't you?
Yeah.
I would love to, jump on that, but cannot really say too much.
Any more?
could this kind of be achieved like if you expose like a REST API and then someone could call that, or what is kind of like how is this different from that, or the pros and cons of
So the pros and cons between using Terraform and exposing the REST API.
Yeah.
I mean, you could. I mean, with Terraform, we use in our case we use Terraform to do all our things like connect to PagerDuty and set up our alert schedules and connect to Amazon and set up our machines at Amazon. So this is basically just a nice way and simpler way to define the parsers and stuff like that, instead of having some from Terraform, because that's what we use, call some shell script that would then run against the API. So it's more of a convenience thing. Yeah.
So just to add to that, if I understood correctly what you did, that was that personally I really like to have stuff like parsers in Git,
Yeah.
because then I can apply it to, for example, Vimeo, to have you can always apply it to a new environment. So if you have QA, production, whatever, you can always spin up a new environment and get the exact same settings that you had before.
Yeah.
That's the nice thing about it.
Yeah, and also one of the ways that we test out our stuff at AWS is basically just to set up at least in some situations, set up a full instance, which means Kubernetes and a bunch of different things. And after that's set up, we could really use this thing to just configure the last bits and pieces instead of wrapping it in shell scripts and stuff like that. Yes. Any more questions?
No? Let's give Mark a big round of applause.